draw a really bad picture here, but we'll get some really good pictures in a minute. But if I have a circle, you can draw a tangent kind of anywhere over there. But if I just drew it like this, like a horizontal line, and I know it kind of doesn't look great, but that would be a tangent line because it just touches the circle right there, kind of like on the top. It doesn't intersect it. Think about if the line went through it, it would always cross it in 2 points. The point of tangency is that point where the line and the circle touch. The point that the line and the circle have in common. In calculus, someday, if we take calculus, we spend about the whole first semester talking about tangent lines to curves, and how we can find those slope of the tangent line. So that's when I teach that calculus, I'm always like, remember what a tangent is to a circle? I know what it is. Maybe you will do. A common tangent is just when a line or ray or segment is tangent to more than one circle in the same plane. We're always talking about the same plane, but there is, there is geometry where there's different planes, right? So that's why they say in the same plane, just because you do it. If we weren't in the same plane, right? That's a change. Intervention up there. Not that I was sure. We're going to do this in a minute and say how many tangents could we draw in, but I can definitely draw a line, right, that could be tangent to both of those. That would be a common. So on the next slide, if you've already, you can see it already, it says draw in all common tangents. If no common tangent, state no common tangent. If you have a pen, you might want to be careful in case you make mistakes, so I can scribble it out. But if you'll take a minute or so, and that's a terrible scribble. Take a minute or so and just try on these three. That's just A, B, and C. Not that it's multiple choice, but there's 3 parts here of how many tangent lines, common tangent lines, could you draw in for the 2 circles in A, the 2 circles in B, the 2 circles in C. Hint, I believe C has one. Oh yeah, ruler of knives. You could use another sheet of paper maybe. You would just go chuck it in. Oh, I mean, plug in that. Right, but then they'll just stick right in your eye. Not every. Well, no, that's your one. Okay, here drew this in, and somebody tell me if this is right or wrong.
Wrong.
Why? It can only touch the circle in one spot. So when I see this, it touches here and here and here and here. Right? So that's not right. Does A have any common tangents? Oh. Yeah, so I say this one has none, because if you try to draw in a tangent to that inside circle, it's always going to touch the outside circle in 2 spots.
Does it have to be a full line that you can forever segment?
definition said it could be a ray, a segment, or a line, right? But
Okay.
I feel like it has to be like it. Like Grace said, what about from here to here? But that's not a common tangent. So maybe we should say you can draw a segment, but if it continued, it still couldn't intersect it. Does that make sense? Because that's not a common tangent. So maybe we should say we don't like the word segment in that.
So then,
So, because you're right, if it was a segment, then maybe you could draw one in.
A would have a lot.
And I think that's why I think segment is a bad choice. I just copied the book definition on that, because there's not infinite, unless it's the exact same circle, I guess. Even in the same circle, there's not infinite, I guess. Yeah. So, what about B? I'm gonna draw one eye thing. Like here. Oh, sort of, right? Like it would be tangent here and here. And then on the other side. If it goes through the circle, that means it's going to touch it in 2 points. Do you agree with that, Garrett? Like, if it goes through the circle, it's going to touch it on either side, and that's not a tangent. A tangent can only touch it in 1 point. So I agree with Chandler that there's 2. But it touches, but each circle it only touches once. It's going to touch here, and I know mine doesn't look so great, but it's like that it's just like on top of the circle, and it touches in that 1 point. But it just touches each circle once. And I know like the lines are so thick that it looks like it may be touching more, but the idea is if you zoomed in really close, like there's just 1 point there that I always think of a tangent as it's like lying like right on top of, like just touching. Like if you laid a paper on top. No, that's not a good example. C definitely has 2, but I think it has more. A little tricky on that, but you could draw a line in from here to here, yes? Roughly speaking. And from here to here, roughly speaking. So like here to here, and here to here. Ooh, I think that's cool. Yeah, I mean it's just a separate tangent line, yeah. That's kind of a good practice to kind of understand what is a tangent, what isn't a tangent with 2 circles. So I think there's a couple of those. So then the rest of the notes today are just, what are some properties about tangent lines? It's in a box. I think I'm only going to let you do what's in the box. That's being wrong. But you'll be okay. Like, you need to know what a tangent is. Like, just the theory. I can't give you everything. But, like, this blue box, you can draw that. Which kind of shows you the tangent line. So it kind of, like, I feel like you're going to know what it is. So, it says, in a plane, a line is segment to a circle if and only if it's perpendicular to its radius. So that's a really easy way to prove that a line is tangent, because it's hard to just tell by looking, right? So if it's perpendicular to the radius at that point of tangency, then that's how you know that it's a tangent line. So the example here, line L is tangent to circle S if and only if line L is perpendicular to the radius ST. They're going to ask you to determine whether a line is tangent, and they're going to ask you to say, if it is tangent, find the missing side. And both of them are going to be using this idea that it's perpendicular. So this example 2 says, KL is a radius of circle K. Determine whether LM is tangent to circle K. And you can't just say, yes, it looks like it only touches in one point. You can't say that to prove something. But what we can do is use theorem 10.10 here and say, if it was tangent, we know this is a right triangle. So how can I prove that's a right triangle? Because of that. Right, because if we're talking about length here, and we can't measure a line that goes on forever, but we could imagine that this goes on forever.
So that because like
yeah, if we can prove that this is a right angle, then we can say it's tangent. So Garrett, what could we do to do that? Pythagorean theorem, right? Yeah, so we can say, to prove it's a right triangle, we could just say 20 squared plus 21 squared has to equal 29 squared. Pythagorean theorem says if that's true, then it is a right triangle. So we just have to show that that's true. And that's justify your answer. If you show that, that's enough. You don't have to write it all out. We could write a lot more out there, but I don't know. So this is 400 plus 441. 29 squared is 841. So since it's a right triangle, right? Since Pythagorean theorem is true, then yes, LM is tangent. Yeah, like showing a work is a great justification. Questions about that? Okay, so the other part of that is, what if they tell you it's tangent and then there's missing parts, right? So it says in the figure WE is tangent to circle D at W. Find the value of X. So we can use that same idea, only we're going to have a lot more algebra to do. I would test that in each of the So again, if W is the point of tangency, we know that that's going to be our right angle. And can we do the same thing, Pythagorean theorem, to solve for X here? Except for it's a little more work, right? What's this length going to be? How am I going to write that? 16 plus X, right? So I'm going to say, oh man, this is going to be fun. 16 plus X squared plus, oh wait, is that fine? Oh man, I about screwed that up. Equals, I mean, this side squared, which is just X squared, plus the other leg squared is 24 squared. Any other questions where I'm getting that from? Do you remember how to work this out? It's not just 16 squared plus X squared, right? Because that means there's two of them. We can't just take the square root of both sides because you can't break up addition and subtraction under a square root. So what you have to remember is this is a binomial square. 16 plus X squared is the same as 16 plus X times 16 plus X. I'll work that out. It's algebra. FOIL, yes? So just don't forget, the common mistake that people want to do is they leave out the OI of FOIL. They just want to take 16 squared plus X squared. But we should really be taking 16 times 16. And then the middle part of FOIL, remember, is 16 times X, 16 times X. Are you okay if I go ahead and add those together, or you want me to write that out? So I'm going to say that's 2X, and then the L of FOIL is X squared. Right? It's been a while, I know you know how to do it, but just want to refresh your memory. Yes, it never goes away. In all of your math classes, you're going to be doing FOIL. And so 24 squared is 576. What's really nice here is that we have an x squared on both sides, so those are just going to cancel out. Do you agree with that? That makes it really nice because we don't have to factor or do the quadratic formula. That would be terrible, right? So when I subtract x squared, that just goes away. So I'm just going to move this 256 over here. So I get 32x equals 317. Is that true? Nope, I did. Sorry. Oh, that makes it really nice. I was like, this is going to be really ugly, but I can't. I typed in 573. That's calculator user error. I should have just subtracted it. 10, x equals 10, that works out so nice. Make sure what they ask you to find, right? It's really easy. I miss that all the time. Because a lot of times in this book, they actually ask you to go back and plug it in. But this one, they only ask you to find what x is. But that was a good amount of algebra work there. So, kind of nice review for us. Questions about that? All right, we have two more things. What if you have two tangents? There's a theorem about that as well. So if two segments from the same exterior point, so you have the same point out here, and both of them are tangent to the circle, then those two segments are going to be the exact same length, congruent, which means you're going to be able to solve a lot of problems about that, right? So if AB and CB are both tangent to circle D, they both start at the same point, then we know that AB is congruent to CB, which again means that you have that theorem that you're allowed to write on your paper. You just have to be able to use it to questions like this, and also maybe what if there was a story problem that comes with it, right? And so really easy on this, it says AC and BC are tangent to circle Z, find the value of X. So we just know that we set those equal to each other, which even if you didn't know that, you would probably guess to set them equal to each other, right? That's the go-to thing. So if I subtract 3x over, that's just going to be x, and I add 3 over there, x equals 5. I could solve those all day. We talked about inscribed polygons and polygons circumscribed about a circle. So the last thing is about that. They don't really have this in a box, like a theorem box, but at the top of page 721, if you want to look at it, there's some examples. I'm not going to solve it. But circumscribed polygons means a polygon that's a circle is inside polygon, right? So like this, right? A circle, and then the triangle is around it. A polygon is circumscribed about a circle if and only if every side of the polygon is tangent to the circle. And we couldn't really use this definition until we learned what a tangent was. But the fact that we know that now, right, is like you get these points of tangency on there. And in your book, they give you examples of circumscribed polygons and non-circumscribed polygons at the top of page 721, which is what I put on there. If you want. No. Only in the blue box. Okay, so now it says the round cookies are marketed in a triangular package to keep the consumer's interest. I have no idea that's how that was spelled. I always thought that was okay. So if triangle QRS is circumscribed about circle T, find the perimeter. So here's the idea. Now that you know that these are tangents, you can use these theorems to help you find the perimeter. Well, we already know this whole thing is 8, right? So that's good to go. If I know this side is 10, what else do I know is 10? So the theorem says if we have the same point, that we know Sn, right? We know that, right? I don't think I know that MR is 10. I don't know that. That doesn't say it divides it in half. But theorem 10.8 11, I think, said if we have the same exterior point, then these are both tangent, that if this is 10 centimeters, this is 10 centimeters. So if this is 2 centimeters, does that mean this side is 2 centimeters?
Oh wait, that's what also.
If this is 2, these are both tangent. You have to find that exterior point where they're both tangent. So MR is going to be the same as LR. Do I know what LR is? This whole thing is 8, and this is 2. That means this is 6, and this is 6. So it's not a whole lot of computing on that. We don't have to FOIL anything out, but you have to make sure you use your theorems and you don't just make up things that aren't true. Which means I don't know how we want to add this up. We could just say 20 plus 4 plus 12. How about that for weird? I got 36. Did you get 36? I did the ones that are all the same. You could have said 16 plus 12 plus 8. Either way, you get 36. 36. You can kind of think about where, like, we're not even close to being able to do this, but a big idea with marketing is you want to be able to make a package that uses the least amount of material that can fit your thing in there, right? So we want to make the least cost that's still going to like maximize our profit, and that's something that we do with calculus. That's how we got maximizing profit, minimizing costs, using all that calculus. We kind of think about what that. They waste a lot of packaging here, but they wanted to Pete. Pete? I think it's Pete. It's just weird. I just never knew it spelled like that. Yeah, that's a weird word. I learned some new vocab today. You still have to do English, right? So 9 through 27 multiples of 3, and then I think 41 and 42 are multiple choice, and then I gave you some review problems again, because it's always a good idea to kind of keep reviewing what we've done. So I think the review problems are 40, maybe 42, 44, and 43. So we do have like 15 minutes of work, so everyone needs to get their book open and work on this. If you still have questions about your quiz, that would be a great time to ask me. And other than that, you should be working on this. Remember that you get participation points every day in here for staying awake and their notes and for doing homework when there's time. 7:22-ish, somewhere around that. Are you gonna have internet access? There's no way I'm gonna have at least 50%. Like I seriously wouldn't do that in class, but I will put it on class every day. You're gonna be having test next week, and so you'll have to make that up. But I think, I mean, kind of good and bad. You don't have to make a test up, but I think like review on Monday, test on Tuesday, the plan, it looks like we'll just test spreadsheet on Wednesday. You'll probably only miss like one day of food. So that would be okay, work. Good, I'd seem to fix your grades.